In addition to the role the oceans have in delaying the warming of the climate, we also have to look at other factors which are changing in the oceans, and the most obvious one really is sea level rise. Warmer oceans are causing the ocean level to rise from two different factors. One is that warm water takes up a larger volume. So if we have the same volume to fill up in the oceans, if we warm up that water, it's actually going to rise. It's going to take up a larger volume, and we'll see a sea level rise. But we're also seeing the melting of the ice sheets, particularly Greenland and Antarctica, which are also contributing water to the oceans. And here we can see some satellite data from the 1990s to today. The different colors are different satellites, because satellites don't last forever. And we can see here that the slope, the line which is fitted through this data, is giving us a slope of about 3 millimeters per year, the rise of global sea level. So 3 millimeters doesn't sound that much, but that's 3 centimeters per decade, and you can estimate the changes over a 100-year period. And if we look at the predictions of what may happen in the future from the IPCC report, it again depends on the different scenarios we're going to follow, whether we're going to rapidly move to renewable energies and do everything to mitigate climate change. We'll follow more or less the blue curve here, or if we continue as more or less business as usual, using fossil fuels as we do today and following the red curve. And this plot is going out to 2300, so we're not looking just to the end of the century. And we see that basically by the end of the century, we're talking about around about possibly 1 meter sea level rise, depending again on the scenario around the whole planet. But if we don't do anything, we could get up to, in the worst scenarios, 3-4 meters sea level rise globally by 2300. The problem with sea level rise, it is kind of irreversible. This is kind of one of these tipping points. Once we cause the seas to rise, to reduce that level is extremely difficult. We first have to cool the climate. We have to produce snow, which will fall on the continents, produce ice sheets, so that this can actually reduce the sea level. But these are processes which take tens of thousands of years normally. And first you have to cool the climate. So without cooling the climate, we're not going to produce the snow to produce the ice sheets. So whatever sea level rise we see in the future, we're probably going to have to live with that, even if we can cool the temperatures back to what they were in the 1950s, 60s, and rainfall patterns could maybe return to normal. But sea level, we may have to live with that for a long time. What's the meaning of sea level rise of 0.5 meter, 1 meter by the end of the century? So let's take a look at the Nile Delta in Egypt. We can see the actual sea level in the top image and what will be underwater if we have a 0.5 meter, 50 centimeter sea level rise, or 1.5 meter sea level rise. Alexandria, Port Said will be underwater. If we look at the 1.5 meter, today, there are 8 million people living in this region of 1.5 meters. This is not going to happen from today to tomorrow, but if you're planning for the future, these people are going to have to be relocated. We have to move them somewhere, build new cities. They have to be given also jobs somewhere else. This is also a huge area of agricultural land. This is going to be a huge problem for Egypt if sea level goes up by 1 meter by the end of the century, and 8 million today live there, but the population itself is doubling every 30 years. So in 2050, 2060, we're going to see 16 million people living within that 1 meter or 1.5 meters of sea level rise. Similar problems in other parts of the world. We can see Bangladesh, the implication of a 1.5 meter sea level rise in Bangladesh. Here too, we can see the situation today on the left and the areas underwater in the future. 18 million people live in this 1.5 meter in Bangladesh today, again with population growth, 22,000 square kilometers of arable land for agriculture. Huge implications on these countries in the developing world, which could lead also to another problem of refugees, of climate refugees, which are going to be looking for places to live, places which can provide them jobs. And the issue of climate refugees is going to become extremely important and relevant as the sea level starts to rise. Now, another problem with the ocean related to climate change is what we call ocean acidification. And this is because of the rise in carbon dioxide in the atmosphere is causing a rise in carbon dioxide dissolved in the ocean. And when you dissolve carbon dioxide in water, you produce a fairly weak acid called carbonic acid. And if you put a few drops of acid on a shell, and maybe many of you have done this experiment in school, you start to see bubbles, and it actually eats away at the shells or at corals. And at the bottom, you can see an example of taking a shell and putting it in a slightly acid solution. Basically, the shells disappear, they dissolve. And so increasing the acidity of the ocean is very detrimental for all life forms in the ocean, especially those that have shells or skeletons like crabs or various seafood, and also coral reefs. Coral reefs also are damaged by the acidification of the ocean. And so even if we can cool the climate artificially in the future, by not taking care of carbon dioxide in the atmosphere, we're still going to have increasing acidification of the ocean and the impact on the biological food cycle in the oceans because of the increasing carbon dioxide. And if we look at the actual data of carbon dioxide here in the atmosphere and in the ocean, the red curve here shows you the measurements on the Mauna Loa in Hawaii in the air. So we're getting the increase in carbon dioxide in the atmosphere, scale on the left-hand side. We can actually see the increase in carbon dioxide dissolved in the seawater, measured at this ocean station here of Aloha. The same trend we're seeing in the increase in the carbon dioxide. And in the blue, we can see the ocean pH, the decrease in the pH, which means an increase in the acidity. And while it doesn't look like a significant change from, say, 8.1 to 8, pH scale is a logarithmic scale. And so this is actually a very large increase in acidity, which is going to continue as long as carbon dioxide increases in the atmosphere.